Hello dear students. So as we have finished the theory part of the chapter current electricity, so let us solve some previous year questions from the NEET examination. Okay. So the first question is from NEET 2019. So here we have two circuits given. So let me draw the circuits first. So we have these two circuits. Okay. Now this is voltmeter, this is ammeter, this is another voltmeter, another meter. Okay. This is 10 ohm resistance, 10 volt potential source. This is 10 ohm, this is 10 ohm. Okay, this is 10 volt potential source. Now see, if we have to compare like whether V1, V2 they are equal or they are unequal. So if they are unequal, then which one has greater value or lesser value? Okay. Now if any circuit is given, okay, in current electricity, if any circuit is given, then you have to assume that ammeter and voltmeter, they are ideal. Okay, voltmeter and ammeter, they are ideal. This is the first thing you need to assume or consider. Okay, now what do you mean by ideal voltmeter and ammeter? It means this ammeter has almost zero resistance, because ideal ammeter has very low resistance, and voltmeter, this has infinite resistance. Okay, so this is the thing you need to consider when a circuit involving voltmeter and ammeter is given. Okay, so this is the basic concept. Now if you use this concept, if you see this circuit, okay, now this voltmeter, it is going to measure the potential difference across this 10 ohm resistor. Okay, now this is infinity. This is infinity. This resistance is, now this 10 volt voltmeter, it is going to measure the voltage across this 10 ohm resistor. Okay, now voltmeter has infinite resistance. So that means if you see the equivalent resistance of this part, it will be 1 by 10 plus 1 by infinity. So that is equal to 1 by 10. So that means equivalent resistance, it will be equal to 10 ohm. It will be equal to 10 ohm. Correct? So if this is, total resistance is 10 ohm, this is 10 volt. So that means the current that is flowing through this part, I, it will be equal to V by R. So 10 divided by 10. So that is equal to 1 ampere. So that means the current flowing through this circuit will be 1 ampere. So this ammeter will record a current of 1 ampere. This current will flow through this. So ammeter will say that, okay, the current is 1 ampere. So we got I1 is equal to 1 ampere. And this voltage, see, this 1 ampere current is flowing through this 10 ohm resistance. So this voltage V1, it will be 10 ohm into 1 ampere. So that is equal to 10 volt. So V1 is equal to 10 volt. Okay, so this is for this circuit. Now if you see this circuit, see, this is 10 ohm, this is V2. Now these two are in series. These two are in series. So if they are in series, now what is the value of this resistance of this voltmeter? Ideal voltmeter has infinite resistance. So effectively this 10 plus this is infinity. So again this quantity, resistance of this part, again it is infinity. So if resistance of this part is infinity, so that means this circuit and this circuit are similar, because resistance of this part is infinity. Correct? So for this also you will get the same kind of results. So that means we will have V1 is equal to V2 and I1 is equal to I2. Okay, so I hope this concept is clear to you. So the entire process of solving this question is based on this factor, that ideal voltmeter has infinite resistance and ideal ammeter has zero resistance. So for this question, option D is the correct answer. Achha, next question is from again NEET 2019. Which of the following acts as circuit protection device. Okay, so you have fuse, conductor, inductor and switch. Okay, so this is a quite common question. The answer is fuse. Okay, fuse is a device which is used as a circuit protection device. But one thing you need to know, that though it is not asked in this question, like suppose you have a circuit like this, so two connect wires, okay, power line wire, and they are carrying this to some device. Okay, so this fuse, it will be connected like this. This will be the fuse. So this fuse is always connected in series with the device. The fuse is always connected in series with the device, so that if high voltage comes, this fuse will break and this circuit will behave like an open circuit, and this high current will not flow to the device and the device will be protected. So in a circuit, in a household circuit, the fuse is always connected in series, okay, so that it is able to protect the device from high voltage current. Okay. So next question, this question appears to be a very long question, but it is not so actually. 6 similar bulbs are connected as shown. Okay, this diagram is given. This is not given, but this is given. 6 similar bulbs are connected. So similar bulbs means they will have same resistance. And it is connected to a DC source. So this is the DC source of EMF E. Okay, and 0 internal resistance. So this does not have any internal resistance. So the resistance of the circuit is only due to the resistance of the bulbs, and all the bulbs are identical, so they have equal resistance. Okay. Now the ratio of power consumption by the bulbs when all are glowing, when all the 6 bulbs are glowing, and in situation when 2 from section A, so this is section A, this is section B, so 2 bulbs from section A and 1 from section B is glowing. So you have to calculate the ratio of the power for this case to this case. Suppose power consumption in this is P1, here it is P2 for these 3 bulbs, it is P2, for these 6 bulbs it is P1. So you have to find the ratio of P1 is to P2. Okay. Now see this DC source, it is sending current I. Okay. Now see this current, it has to be divided into 3 parts, and all the parts are identical because all the bulbs have identical resistance. So that means this current, it will be divided into 3 equal parts. So here it will be I by 3, here it will be I by 3, this is I by 3. So this current will go in this direction. This is I by 3, I by 3, this is I by 3. So that means current flowing through each bulb, in this case it will be I by 3, and all the bulbs have equal resistance, so let it be small r, r. Okay. So we know the current, we know the resistance. So power consumption by a single bulb P, it is the formula for power is I square r. This is the formula for power consumption. Okay. So here power consumption for a single bulb, if we see, it is current is I by 3, resistance is R. So I by 3 square into R. This is the power consumption by single bulb. And how many bulbs are there? 1, 2, 3, 4, 5, 6. So total power consumption, it will be equal to 6 times of this. So this is suppose P1. So this is the power consumption in this case. Okay. So this is how much? This is I square by 9. Okay. I square by 9. So this is 2. This is 3. So P1 is equal to 2I square R by 3. 2I square R by 3. Okay. Now how about this? Now here again this cell is going to send current I. Now this current, it will be divided as I by 2, this is I by 2, and this I by 2 gets combined, so this is I, correct? So here power consumption will be, here it will be I square by 4 into R, I square R, so I by 2 square into R. This is I square by 4 into R, and this is I square R. So this is total power consumption in second case, P2. So this is how much? I square 4. So this is 4 plus 1 plus 1. So that is 6 I square R by 4. So that is 3 by 2. So P2 equal to 3 I square R by 2. Okay. So we have to find P1 by P2. So P1 by P2, it is 2 by 3. I square R gets cancelled. So 2 by 3 divided by 3 by 2. So that is into 2 by 3. So that is 4 by 9. Okay, 4 by 9. So the required ratio is 4:9. Option B is the correct answer. So next question, you have a meter bridge, okay, and the balance position is P by Q, it is equal to L1 by L2, okay. If we now interchange the position of galvanometer and cell, will the bridge work? If yes, what will be the balance condition? Okay. Now see, we know that meter bridge it works on Wheatstone bridge principle. Wheatstone bridge principle. Okay, meter bridge works on Wheatstone bridge principle. Now, in a Wheatstone bridge, suppose if I draw this Wheatstone bridge, this is P, this is Q, this is R, this is S, this is the galvanometer, and this is the battery. Okay. Now we say that under balance condition, P by Q is equal to R by S. Balance condition means no current flows through the galvanometer. So when no current flows through the galvanometer, under that condition, P by Q equal to R by S. Okay. And we have also studied that even if the position of galvanometer, see galvanometer is between, suppose this is A, this is B, this is C, this is C, and this is D. Okay, this is junction A, junction B, C and D. Okay, so between B and D, two opposite junction, we have connected the galvanometer, and between two opposite junction A and C, we have connected the battery or the cell, and we are writing this condition. But see, this condition is equivalent to P by R, which is equal to Q by S. So when I am writing P by R equal to Q by S, this is P by R equal to Q by S, P by R equal to Q by S. But when I write P by Q equal to R by S, this is P by Q equal to R by S. So that means, see, it doesn't matter whether galvanometer is connected between B and D or A and C. So even if you interchange the position of galvanometer and this battery, this balancing condition is not going to change. Okay. Now since meter bridge works on Wheatstone bridge principle, so the same thing applies over here. So here again, it is given that if we now interchange the position of galvanometer and cell, will the bridge work? Yes, it is going to work. And if yes, what will be the balance condition? Balance condition will remain same. So P by Q is equal to L1 by L2. So option this D, P by Q equal to L1 by L2. That is the correct answer. Okay. So next question is, a set of n equal resistors of value R, each are connected in series to a battery of EMF E and internal resistance R. Okay. So we have resistors, n resistors. This is connected to a battery of EMF E and internal resistance R, and these resistors have also resistance R. Okay, and the current which is flowing is I. Okay, I is the current. Okay, so what is the relation between I and all these quantities? I, it will be equal to E. This is N resistance, so NR, and it is in series with this. So total effective resistance will be this combined resistance is NR. It is in series with this, so it will be R plus NR. Okay, so this is I equal to E divided by R plus NR. Now again the current is I. Now N resistors are connected in parallel to the same battery. That means these resistors are connected in parallel. Okay, so this is resistance. So these are N resistors connected to the same battery. So that means same internal resistance ER, and all these are R. Okay, now these are N resistors in parallel. So their resistance will be R by N. Total resistance will be R by N, and that is in series with this resistance. So here the current will be E divided by R plus R by N. Okay, but second case, what is the current drawn? Current drawn here, it is 10 times I. It is 10I. Okay, and what we are asked, we have to find the value of N. Options are 10, 11, 20 and 9. Okay, if you want, you can try this question on your own by pausing the video, and then you can compare with my solution. Okay, now this is, in this case, the current is 10I. So EMF divided by resistance, this is equal to 10I. Okay, so this is N, this is N. So this NR plus R, I can replace this quantity. From this I can write R plus NR, it is equal to E by I. So this is E by I. So this E gets cancelled. I goes here. So this gets cancelled. So N is equal to 10. So the value of N is 10. Okay. So if you see the options, option A is the correct answer. So next question you have, a battery consists of variable number N of identical cells. Okay, N cells are there, having internal resistance R. So each have resistance R, which are connected in series. Okay, so we have cells, N cells, identical cells. Okay, so each have EMF E and internal resistance R. Okay, they are connected in series. The terminals of the battery are short circuited and the current I is measured. Okay, now see, suppose this is connected to, ideally what happens when we have cells in series, so this is connected to an external resistance R. Okay, so here N cells are there, so I, it is equal to NE, this is the total EMF, total internal resistance is NR, and this NR is in series with this R, so total resistance will be NR plus R. So this is the formula for current. This is the net current I that flows in the circuit. This is the normal case. But here it is given that the terminals of the battery, see this is the entire combination, this is the battery, these are individual cells. So this entire combination, this is the battery and this is the positive terminal and this is the negative terminal. Correct? This side we have the positive terminal, this side we have the negative terminal. Okay. Now it is given that the terminals of the battery are short circuited. Short circuited means the positive and the negative terminals are connected with a connecting wire. Okay. Now when it is connected by connecting wire, now in a circuit, in circuits, these connecting wires are assumed to be having zero resistance. Okay, connecting wire does not have any resistance. Normally it has, theoretically it has, but in a circuit, if a drawn circuit, only this shows resistance. Suppose this is R, this is R, this is R, this is capital R. This is given resistance is R, this is given resistance is small r internal resistance. Those things are there. But connecting wires, these wires don't have any resistance. So when you are short circuiting, that means you are connecting the positive and the negative terminal. So if you are connecting the positive and the negative terminal, so that means this part is removed from the circuit. Why it is removed from the circuit? Because if suppose current has two options, okay, this current comes to this point, it has two options. Like here resistance is R1, here resistance is R2, and suppose R1 is less than R2. So here current will flow in both path, but suppose here resistance is less, so more current will flow. Here current resistance is more, so less current will flow. Okay, but if current comes to a point and two paths are available, and here resistance is in 0 and here is resistance is some R, so in that case the entire current will flow through the path having 0 resistance. So that means here the current will flow in this path and this path will be removed from the circuit. So effectively this R will become 0. So when the battery is short circuited, this capital R becomes 0. So this NN gets cancelled. So I is equal to E by R. Okay. Now I equal to E by R, and see what is the graph drawn? Graph is drawn between I and N, current and number of cells. Okay. Now see number of cells. This expression is independent of N. I independent of N. That means when the battery is short circuited, the current flowing in the circuit is independent of the number of cells. Okay, it only depends on the EMF of a single cell and resistance of a single cell. Okay, so that means if a graph is drawn between I and N, so since I is independent of N, so this is I, this is N, so current is going to remain constant. So even if you change the value of N, the current is not changing. So option A is the correct answer. Now next question, you have the resistance of a wire is R ohm if it is melted and stretched to n times its original length. The new resistance will be, the options are given R by N, N square R, R by N square and NR. Okay, so basically see this wire, this is the wire, length L1, area is A1. Okay, now it is melted, okay, and stretched, so this becomes like this. So this is L2, area is A2. Okay, so see we have this relation R is equal to rho L by A. R equal to rho L by A. Now this relation says that resistance is directly proportional to length when area is constant. Okay, resistance is directly proportional to length when area is constant. Similarly, resistance is inversely proportional to area when length is constant. Okay, but in this case length and area both are changing. Okay, so for this if I take R1 is equal to rho L1 by A1, this is R2, it is equal to rho L2 by A2. Okay, Achha. Now see this is melted and then stretched, so that means mass is constant. Mass is constant. Now if mass is constant, this implies volume is constant. Volume is constant, correct? Mass, if mass is constant, because density is not going to change. So if mass is constant, volume is constant. Now what is the volume of this? It is L1, A1. What is the volume of this? It is L2, A2, correct? So if we divide, so this is equation 1, this is equation 2, and this is equation 3. So if we divide 2 divide by 1, so we have R2 by R1 is equal to, this row gets cancelled, so this is L2 by L1, A1 by A2, correct? Now from this we have A1 by A2, it is equal to L2 by L1, correct? So this A1 by A2 can be replaced by L2 by L1. So L2 by L1, L2 by L1. So this is L2 by L1 square, correct? Achha. Now it is given that L2 it is equal to n times L1 because it is stretched to n times its original length. So this will be n square. So isn't it? Because L1 will get cancelled. Okay. So here it is. So resistance, what will be the new resistance? See, R1 is equal to R. Initial resistance is R. So R2 will be equal to n square times R. N square times R. So if you see the options, option B is the correct answer. So next question, you have a potentiometer is an accurate and versatile device to make electrical measurements of EMF because of the method involves. See, options are given: potential gradient, condition of no current flow through the galvanometer, combination of cells, galvanometer resistance, and cells. Okay. See, potentiometer is a better instrument than voltmeter because of this drawback that voltmeter draws current from the circuit. Okay, voltmeter has a finite resistance, but potentiometer is an ideal voltmeter. Okay, so this I have discussed in the topic of potentiometer, that what is the difference between potentiometer and voltmeter. So basically, potentiometer, see, if we have a resistance, suppose this is 10 ohm. Okay, I'm explaining it once again, though I have discussed this in another video, in that video of potentiometer. See, this is 10 ohm resistance. So suppose 10 ampere current comes. Okay, now if we connect a voltmeter, so this 10 ampere current flows through this 10 ohm resistance. So voltage across this 10 ohm, it should be 10 into 10, so that is 100 volt. 100 volt. Okay, so this voltmeter should read 100 volt. But actually what happens when this current comes, so some current flows through the voltmeter. So suppose this is 1 ampere, so here it is 9 ampere, so here the voltage is 10 into 9, so 90 volt. But actually actual reading should be 100 volt. So this voltmeter is not showing the actual value. Why? Because it is also drawing some current. Why it is drawing some current? Because this circuit does not have infinite resistance. If the circuit, ideal voltmeter will have infinite resistance. Okay, ideal voltmeter will have infinite resistance. So if the resistance is infinity, no current will flow through this path, entire current will flow through this path. Now potentiometer. Now this works on the principle of null deflection. That means in a potentiometer you are going to take that reading when the galvanometer shows null deflection. And when the galvanometer shows null deflection, that means you are not drawing any current from the circuit. And when you are not drawing any current from the circuit, it will give the accurate measurement. Okay, so that is the reason. So here option B, that is condition of no current flow through galvanometer, this is the proper reason. So option B is the correct answer. So next we have a question based on circuit. Okay, so this is the circuit consisting of cells and resistors. So this point is at potential VA. This is 2 ohm. This is 3 volt, high potential, low potential. This is 1 ohm. This is at potential VB. Okay. Current flowing I is equal to 2 ampere. 2 ampere current is flowing from this end to this end. Okay. And we are asked to find the value of VA minus VB. VA minus VB. Potential difference between these two ends. Okay. Now if you want, you can pause the video and definitely you can try. Okay. Now see, to find the potential difference, I am going to use loop rule. Now loop rule, see, as per NCERT, now loop rule is like it is for a loop. Okay, and for a loop we say that if we add the potential difference across cells and resistors, the total potential difference will be 0. That is the loop rule. Okay, but actually this loop rule is valid for any 2 points on a circuit. Means between any 2 points, if you find the sum of the potentials, the sum of the potentials will be 0. Okay, so how to use that concept for this circuit. So we have to start from A, we have to go to B. Current is going from A to B, this end to this end. So we will consider this to be at high potential and this to be at low potential, because current is flowing from this end to this end. Okay. So high potential, we will mark it as positive potential. So we are starting from this point. So it is plus VA. Okay. So see, try to concentrate, and this is how we use loop rule for an open circuit. Open circuit means, see, this is a large part of the circuit. This is not open circuit. Current will flow, not flow like this if the circuit is open. Obviously, this is part of a large network, but in that network, we are studying from this point to this point. Okay. So we are starting from this point. So this is plus VA, high potential. And now this current flows from this end to this end. Current always flows from high potential to low potential. So high to low means loss in potential. Loss in potential means minus sign. So minus current into resistance. So this is 4. Okay. Now again, this is high potential, this is low potential, high to low loss. So minus 3 volt. Okay. Now again, this 1 ampere current will flow through this. 2 ampere current will flow through this. 2 ampere. So again, current is flowing from this end to this end. Current always flows from high potential to low potential, high to low, and loss. We are moving in this direction now. We are moving in the direction from high potential to low potential. So there is a loss in potential. Loss in potential means minus sign. So minus 2 into 1. Potential is current into resistance. 2 into 1 is 2. We started from this point and we have considered that to be at high potential. So this point is at low potential. High potential, positive sign. Low potential, negative sign. So minus VB. So we are adding all the potentials and this sum is equal to 0. Okay, so this is how you have to use loop rule for such circuits. Okay, so we have to find VA minus VB. So VA minus VB. So this is 4 plus 3, 7. This is 9 minus 9. So this goes to the other side. This is 9 volt. So plus 9 volt. So if you see the options, option D is the correct answer. So next question, we have a filament bulb whose power is given. So it is 500 watt at 100 volt. Okay, this is for the filament of the bulb. Is used in a 230 volt main supply. Okay, so this bulb works when it is provided a voltage of 100 volt, but now it is connected to a circuit where the voltage is 230 volt. When resistance R is connected in series, it works perfectly and the bulb consumes 500 watt. So find the value of R. Okay, so here, so this is resistance R and this is the bulb and it is connected to 230 volt source. Okay, now here it consumes 100 volt. Okay, so here bulb consumes 100 volt, so that means here the potential drop, it has to be, total is 230, 100 is, only bulb should get 100 volt. So that means this resistance which is connected, the potential drop across this resistance, it must be 130 volt. 130 volt. Okay. So now see here 130 volt is to be dropped across the resistor, then 100 volt will be available to the bulb. Okay. Now what is the resistance of this bulb? We need to know the resistance of this bulb. Okay. Now power is given, voltage is given, P, it is equal to V square by R. So from this, see, this is power of this bulb, this is voltage rating, so resistance R, this is R, resistance of the bulb. So this resistance of the bulb RB, let it be RB. So RB, it will be V square, so there is 100 into 100 divided by 500. So this is 20 ohm. Okay, so RB is 20 ohm. So if RB is 20 ohm, voltage is 100 volt, so that means the current which is flowing through this I, it will be equal to V divided by R. So 100 divided by 20, so that is equal to 5 ampere current. Now these two are in series, so that means current flowing through this is 5 ampere, isn't it? Now voltage is 130, current is 5 ampere. So what will be the resistance? Resistance will be equal to 130 divided by 5. Okay, so this is 26 ohm. So 26 ohm is the value of the resistance. So option C is the correct answer. Achha, next question you have a potentiometer wire is 100 centimeter long and a constant potential difference is maintained across it. Two cells are connected in series, first to support one another and then in opposite direction. The balance points are obtained at 50 centimeter and 10 centimeter from the positive end of the wire in the two cases. Find the ratio of the EMF. Options are given. Okay. See, here, first of all, you need to understand what is the meaning when cells are supporting each other. Okay. First, it is given that two cells are connected first to support one another. So that means the cells are connected like this. This is E1, this is E2. Okay. When they are opposing each other, that means the cells are connected like this. This is E1, this is E2. Okay. Achha. So this is the first thing that you need to understand from the question. Now the other thing you need to understand that for potentiometer, the concept is this potential drop is proportional to the length, balancing length. So that is E is equal to KL, where K is the proportionality constant and it is called potential gradient. Potential gradient. Okay. We are not going to use anything about potential gradient, but you should know this. This is the principle of potentiometer. Principle of potentiometer. Okay. Just the knowledge of this concept is going to help you to solve this question. So when this supports, so that is total EMF will be E1 by E1 plus E2. It is supporting, and when it is opposing, it is E1 minus E2. So this is the net EMF in this case. This is the net EMF in this case. First case, the balancing length is 50 centimeter. So that means this quantity is proportional to 50, and here this quantity is proportional to how much? Second case it is 10 centimeter. So this is 10. Okay. So this is equal to K times 50. This is equal to K times 10. So if we add these two quantities, okay, if we add these two, so this E2 gets cancelled. So 2E1 is equal to K times 60. So that means E1 is equal to 30K. So E1 equal to 30K implies E2 is equal to 20K. This is 30K, so E2 will be 20K. So that means ratio of E1 by E2, it is equal to 3 by 2. Ratio of the EMF is 3 by 2. So option B is the correct answer.